The one characteristic of the angular contact ball bearing, used in the industrial field. It can bear both radial load and axial load. When the bearing begins to bear the load, the inner and outer rings and the rolling elements approach each other and finally contact each other. At this time, the angle between the normal of the contact point and the plane perpendicular to the bearing rotation axis forms the contact angle. With the increase of bearing load, the original contact point is compressed and deformed. Then the contact point becomes larger, and it will change from point contact to surface contact. With the increase of contact area, the radial and axial rigidity, preload, of the bearing also begins to increase. In a word, the function of contact angle is radial axial load distribution or load transfer. For example, the deep groove ball bearing is only subjected to radial load under most operating conditions. Under pure axial load, contact angle is 0. The thrust ball bearing under pure axial load, contact angle is 90. However, for many mechanical devices, the application of angular contact ball bearings needs to bear both axial and radial forces. Therefore, the contact angle of angular contact ball bearings that need to be stressed simultaneously in radial axial is always greater than 0. How does the contact angle of the bearing affect the distribution of radial axial loads? For example, when the contact angles of the angular contact ball bearing are 15, 17, 25 respectively, the ratios of radial and axial rigidity, that is, preload, are respectively 5.6, 4.7, 2.1. The load capacity of bearings represents the cutting capacity of machine tools processing. Thus, what is the deep connection between bearing contact angle and machine tool processing? Please look forward to next video.